So good morning everyone. So this is going to be the graphical method of the tree vector to find the vector resultant. First we are going to draw a graph that is labeled as the north and the east. And now we are going to measure the degrees, which is 30 degrees for the vector 1. Put a line on the degrees. And now we will label it 30 degrees. Northeast for the direction is from east to north. Then the length that is needed is 50 meters. And our scale is the scale would be 1 centimeter is equal to 10 meters, or 10 meters is equal to 1 centimeter. So now we are going to measure the 50 meters for this in the line of the angle, where we will stop at the 5 centimeter. We will highlight that line and put an arrow to the head, and the tail would be the center of the graph. The next vector would be the 30-meter east. So we're gonna put another graph from the head of the first vector, because that would be the start of the tail of the second vector. So we're gonna stop at the third centimeter, since it's 30 in our scale. Now down to our third vector, which is 50 meter north only. So we're going to draw a line from north, or the x-axis only, since there is no east. And after that, we'll highlight the line up to 5 centimeter, because that would be our 50 meters. Now we are going to measure the tail of the first vector to the head of the third vector. We will measure it by according to our scale also. And for our new degrees, we are going to measure it using the protractor. In this example, the degrees would be 46 degrees. At this point, we are going to solve our vector resultant by VR divided by 10.8 meter. So we just need to follow the steps and use this formula to get our vector resultant. So our vector resultant now is 108 meter and 46 degrees northeast. This method is what you call the graphical method. Next would be the component method using the trigonometric function. Using the parallelogram or the component method. So first let us draw our triangle. So let's draw a triangle with the hypotenuse already as our example, and we will going to find out the adjacent and opposite. Suppose we have 7 meters. Our adjacent is still missing, and our opposite is also missing. So in solving this, you're just going to use the formulas that will be shown in this video. So let's just follow that. Here is the formula to get first our opposite. We have to use for opposite. Okay, we have to use sin theta is equals to the degree of this is 30 degrees. So we have to put 30 degrees. So sin
theta equals opposite.
For us to get the opposite, we need to use the formula sin theta. Sin theta equals opposite over
Then
hypotenuse.
we have to get the hypotenuse and the theta to solve the problem. So our theta is 30 degrees equals to the opposite, which is we are going to find, then the hypotenuse of 7 meters. So now let's have here our opposite, since that is the part we're going to find, and our 7 meter multiplied by sin 30 degrees, that would be equal to let's use our scientific calculator. Oh yeah, there's already 8. So 7 times sin 30 degrees, that is equal to 3.5. 3.5, the measurement is meter. So that is now our opposite. Sorry how we're going to put it here. 3.5 meter. Wala na ang question mark since we already found. For the adjacent here, going to use cos. Cos theta equals adjacent over hypotenuse. So this is for adjacent. So our cos
For the adjacent, we're going to use cos theta equals adjacent over hypotenuse.
Our adjacent over our hypotenuse, which is 7 meters. And okay, so we are going to transpose this one, so this is going to be now our adjacent. That is equal to 7 meter times cos 30 degrees. So our new adjacent now is, we're going to use our scientific calculator. So 7 meter, times cos 30 degrees. This is equal to 6.06. It's 6.062 or 6.06. So this is our new adjacent. We're going to put it now in here, our new adjacent, which is 6. Let's not forget the meter. I'm sorry. 6.06 meter. So yes, that is our adjacent now. In order to get the degrees, we have to use the formula. This is for our theta. And theta goes opposite.
And for the theta, we're going to use tan theta equals opposite over adjacent.
So our opposite is 3.5 meter over our adjacent 6.06 meter. That will be equal to, let's check. .5 times 6.06 21 point. Oh, sorry. So this is I'm sorry. This is 3.5 divided by 6.06. Okay, so it's 0.5775, and so shift 10 of 0.5775. Then we get our, so we have to put here shift delta of, oh, this is shift 10, I'm sorry, of 0.5775. That would be equal to 30. Yes, 30 degrees. So this is our 30 degrees here. That's all. So again, the second method is what we call the parallelogram or the component method using trigonometric function. There is also another one, which is our using the Pythagorean theorem. I was recording the Pythagorean theorem, the video just stopped, so I finished the solving, but I didn't get the video, so let me just explain it to you. So the Pythagorean theorem formula is the a squared plus b squared equals c squared. So our a squared here is the 6.06 meter. I am just going to use this example from previous example of the trigonometric function. Then plus the 3.5 meter, our b squared equals to VR squared. So C is equals to our VR squared. So that will be equal to 6.06 meters squared plus 3.5 meters squared. So in order to get the equivalent for this, we need to square root the a squared plus b squared. So transferring it here, then the 6.06 meters squared is equal to 36.7236 plus the 3.5 meters squared is equal to 12.25. So if we're going to add this one, the result will be 48.9730. So again the video just stopped. So let's continue. 36.7236 plus 12.25 is 48.97336, and the square root for that is 6.998 meter. That was our vector result.